In this first video, we're going to go over all the problems from the 1.1 section from the homework. So let's do a bunch of problems that are similar to the ones that you need to do, and then you guys can copy those steps when you're doing them on your own. So from section 1.1, the first problem that we'll go over with is going to be multiplying two things that look like this together. So we can do, say, 2x plus 7y, and then we can multiply this to, let's do just x minus y. So this could be a review. Whenever we're multiplying two things like this together, so we start with the piece on the left. So this 2x right here, which is the first thing in here, we're going to multiply the 2x to this x, and then we're going to multiply this 2x to the y. And then the 7y, we're going to take the 7y and multiply it to the x, and we'll take the 7y and multiply it to the y. So from the first one, 2x times x, that's going to be 2x squared. Then 2x times minus y is minus 2xy. 7y times x, that's 7xy. And then 7y times a minus y is a minus 7y squared. Okay, so now that's the first step. We take this 2x, we multiply it to the x, we multiply it to the y, and we take the 7y, multiply it to the x, multiply it to the minus y, and we're left with this. And then now what we would do is see if there's any like terms that we can add together. So this one there's only one x squared term, it's this one. So all we have is that. But here's an xy and here's an xy, so we have two of those, so let's group those together. And then here's a y squared term, we only have one of those. So there's nothing to combine this x squared term with, so we just write 2x squared. But here we have a minus 2xy plus a 7xy, so we're going to get 5xy. And then we have just the y squared term, so minus 7y squared. And so this would be our final answer. And so something that we did in this problem, for example, let's say on this first bit, when we did 2x times x, let's just write that off to the side, 2x times x. We remember that whenever you have just, an x times an x, a way we can write that is x to the power of 2. So we can write this as just 2 times x, so 2 times x squared. So that's why we have an x squared here. We have the x times the x, that gives us an x squared. And same with this y squared. So here we have the 7y times the minus y. So we're going to get a minus 7, and then y times y is y squared. So for the first problem, this will take care of that. Let's do another one, something similar to like the part A. So this next problem that we're going to do, let's do minus a plus b times a plus b plus c. So we're still going to do the same thing. We'll take care of this minus sign at the very end. We're going to take this a and multiply it to each of the pieces in the second group of letters. And then we're going to take this b and multiply it to each of the pieces as well, just like we did in the previous one. The previous one we only had two things, so this went here and it went here. But now the a has to go here, here, and here. And then we'll take care of this minus sign at the very end. So let's rewrite the minus sign. And this minus sign belongs to everything. So let's just put a big bracket, and then we'll put this whole piece just inside this bracket. So here we have an a times an a, so that's an a squared. An a times a b, so just ab. An a times a c, which is ac. B times an a, or that is ab. B times a b is b squared. And b times a c is bc. Okay, so we still have this minus sign. So now let's combine all the like terms again. So only one a squared term. Here we have an ab, but we also have an ab right here. Here's an ac. We only have one of those. Here's a b squared. We only got one of those, and then here's a bc. So we only have one a squared term. Let's just rewrite that. Here we have an AB and an AB, so we have two of those. So we can put 2AB. We only have one AC, so we're going to put the AC down. Let's put this on the very end. So let's put the BC next, and then the B squared at the very end. Okay, so now we've combined all the like terms in here, but we still have this minus sign. So now this minus sign needs to distribute to everything. So the minus sign has to go here, 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 and then also here. So what we're going to do is have a minus a squared, a minus 2ab, a minus ac, a minus bc, and then a minus b squared. Okay, so these two problems that we said will take care of the first bit of the problems on the homework. All right, so let's move on to the next example. So this will be for similar problems to the problem 2 from this first bit of homework questions. So this whole problem, this is the third problem we're doing right now, it's all about just manipulating or adding and subtracting fractions. So let's just go through an example with each one. Let's start with adding fractions. And we'll also do subtract since they're both the same thing. So let's start with 2/3 plus 7 over 4. So when we're adding fractions, we need to make sure that the number on the bottom of each fraction is the same, and then we can just add the tops together. So right now the bottom of this fraction is a 3 and the bottom of this fraction is a 4. So we need to find a way to make this 3 and this 4 be the same number. But what we can do is we can turn both of these into a 12. So if we multiplied this one by 4, we'd have 4 times 3, which is 12. And if we multiplied this one by 3, we'd have 4 times 3, which is 12. So what we're going to do is take this first fraction. We're going to multiply a 4 on the bottom, but we're also going to have to multiply a 4 on the top so we don't change the number. Plus, then we have this one right here, 7 over 4. And then to make this one a 12, we're going to multiply a 3 on the bottom, but also a 3 on the top. So what we end up getting is, here is 4 times 2, which is 8. And 4 times 3, which is 12. Plus 3 times 7 is 21. 3 times 4 is 12. So what we just did is we manipulated the original problem to now have the same denominator in each of the fractions. And once we have the same denominator, we can just add the tops and rewrite the denominator on the bottom. So the denominator is 12, and now we're going to add these tops. So 8 plus 21, which is going to be 29 over 12. Okay, so now let's do an example with subtraction. We can subtract 8 over 3 minus, and let's do 2 over 7. Okay, so just like with addition and subtraction, you need to make sure when you're combining these fractions that the numbers on the bottom are matching. So like here, they weren't matching, but we manipulated it and made them to be the same. We turned these both into 12. We have to do the same thing for this problem. So what we need to do is somehow figure out a way to turn this 3 into a number and the 7 into a number and have those numbers be the same. So we can both turn these into a 21. So what we're going to do here is take our first fraction, 8 over 3. To turn this into a 21, we can multiply this bottom by a 7 and the top by a 7. We have our minus sign, 2 over 7. And then we could turn the 7 into a 21 by multiplying a 3 on the bottom and then a 3 on the top. So what we end up getting is here is 7 times 8, which is 56. 7 times 3 is 21. 3 times 2 is 6. And then 3 times 7 is 21. So now we have the same denominator. We both have a 21 now. And so what we can do is write one fraction with just the 21 on the bottom. And now we can do 56 minus 6, which is just going to be 50 over 21. Okay, so there's just two examples of how we would add and subtract fractions together. So let's do an example of when we're multiplying and dividing fractions together, which we kind of actually already did. We already multiplied fractions. We multiplied these two fractions together. And you see when we multiply fractions together, all we do is multiply the tops. So 4 times 2 is 8, and we multiply the bottoms. 4 times 3 is 12. So when we're doing multiplication and division, we don't need to worry about making the bottoms of the fraction be the same. That's only with addition and subtraction. So for example here, this is the fourth problem. Let's do multiply and divide fractions. So let's just do something, I don't know, like 2 over 7 times 11 over 3. So just like we said a second ago, when we're multiplying fractions together, it doesn't matter what the bottoms are. Every time all we do is we take the tops, multiply them together, and take the bottoms and multiply it together. So we're going to multiply the tops, just 2 times 11, and then multiply the bottoms, 7 times 3. So 2 times 11, that's 22. 7 times 3, that's 21. So when we multiply these two fractions together, 2 over 7, 11 over 3, we get 22 over 21. Okay, our next example, let's do a division one. So let's say if we want to do 13 over 6 divided by 5 over 3. So whenever we're dividing fractions, so you're given two fractions. One on this side, we have our division symbol, one on the other side. So how we do these problems is you just rewrite the first fraction, 13 over 6. You write a multiplication sign, and then you turn the second one upside down. So instead of having it 5 over 3, we're going to write this as 3 over 5. And then all we need to do now is multiply these two fractions together. So whenever we're dividing two fractions, this is always the case. You take the first one, just rewrite it. So we're dividing by 5 over 3, so we put a multiplication sign, get rid of this sign, and then you turn the second one upside down. So instead of it being 5 over 3, now it's going to be 3 over 5. And then we just multiply these two fractions together the same way we did in the previous problem. So we take the tops, multiply them together, 13 times 3. Then we take the bottoms and multiply them together, 6 times 5. And 13 times 3, that's 39. And 6 times 5 is 30. So there's another way we can write division. So there's this division symbol, but we could also do this problem as, let's choose different numbers. How about we do, so 2 over 7 divided by 6 over 5. So this right here, this would also be the same way of writing, so if we want to write it in this form, the thing on the top would be on the left-hand side, and then the thing on the bottom right here would be on the right-hand side. So this would be 2 over 7 divided by 6 over 5. So this 2 over 7 would go right here, and the 6 over 5 would go right here. So again, whenever we write a problem like this where we have fractions and we're dividing it by another fraction, but we're writing it in this form, not this form, we still sort of do the same thing. In this situation, we're just going to take the top and rewrite it, 2 over 7, put a multiplication sign, and we're going to take the bottom one and turn it upside down, 5 over 6. And then we multiply the two fractions together. So we're going to have 2 times 5, which is 10, over 6 times 7, which is 42. Okay, so then for this, there's these three problems, so we'll get these three answers. Okay, so let's go over now the last problem from this section. So this is intervals. This will be what we're going to be talking about for the last bit of this section. So what an interval is let's start with like a number line. So let's put a number on here. Here's 2, and here's 7. And let's say we'll explain what these mean in a second. Let's put a circle on the 2 here, and then a closed circle on the 7, and then we'll shade in between. So what we just shaded was an interval. We shaded everything from 2 into 7. But what this circle means is we're not, 2 is not included inside of this interval. So it's just all the numbers that are bigger than 2, but once you get to 2, you don't include it. What this closed circle means is you do include the 7. So all these numbers right here, one way we can write this is, so let's call all these numbers just, x or whatever. So all these x's, they have to be bigger than 2, but less than or equal to 7. So any number in between, strictly bigger than 2, but less than or equal to 7. So one way this notation up here is called graph notation. This you don't really need to worry about, but the other notation you would need to worry about is something called interval notation. So these are the two notations that you'll have to know: graph notation and interval notation. So this is graph notation. And if we want to put this into interval notation, the way we write it is parenthesis 2, 7 with a bracket. And so what this means is these are all the numbers in between 2 and 7. And whenever we have a circle relates to a parenthesis. And whenever we have a closed circle relates to a bracket. So say like another example, just be like the first one we're doing here. Another example we could do, so say if we have this interval, -3 up to 1. And we want to turn this, which is interval notation, we want to turn this into the graph notation. So we have to put on a number line. So we have -3, 1, and we said a bracket relates to a closed circle. So we have a bracket on the -3, so we're going to put a closed circle on the -3. And then we have a parenthesis on the 1, so we're going to put a circle on the 1, and then you shade in between. Okay, the last thing from this too, so say if we want to graph, or we're given this, say here is -6, put a closed dot on that, and just shades on forever in this direction. So what we're doing is you're going -6 all the way up to infinity. So the way, say if we want to turn this into interval notation. So it starts in graph notation, we want to put this into an interval notation. Okay, so we have -6 with a closed dot, so we're going to put a bracket with -6. But then this goes up to infinity. So we're going to put infinity right here. And no matter what, infinity always gets a parenthesis. So whether it's a positive infinity or a negative infinity, we always have a parenthesis with infinity. So then this little section right here, the -6 all the way up to infinity, that's how we write it. This is with a bracket on the -6 because we have a closed dot, and it goes all the way up to infinity.